Hello guys, today we'll be doing a new project, Touchless Doorbell. This project is very useful to us right now because we need to maintain social distancing at in this time of COVID-19. I think this project of mine will help in maintaining social distancing as COVID-19 will spread through contact. By bringing our hands near to the sensor, there will be no direct contact and the doorbell will ring. Okay, in this project we have used some components such as Arduino Uno, a PIR sensor, piezoelectric buzzer, a 1K resistor, 16x2 LCD display, and a potentiometer. Then finally we have used some connecting wires to connect all these components together. We have used the breadboard as the basement for all of these connections. Okay guys, so before we start the simulation, let us have a look at the code. Okay, here the code we are importing this header file liquidcrystal.h. As we are using an LCD display over here, so we are importing this header file and int signal pin is equal to 2. Okay, the signal pin, okay, we are declaring the signal pin connected to the Arduino, okay, which is pin number 2. Buzzer pin is assigned to Arduino pin number 3. That is, we are declaring the positive pin of the buzzer which is connected to Arduino. The negative is grounded. And these pins RS, EN, D4, D5, D6, D7. These are the pins on the LCD display over here. You can see this. We are connecting these pins RS. For example, let us take RS. We are connecting to pin number 12. EN to pin number 11, D4 to pin number 7, D5 to pin number 6, D6 to pin number 5, and finally D7 to pin number 4. Okay, the liquid crystal, we are not going to use this name again and again, so we will be declaring it as LCD1 throughout our code. And LCD1, of course, it has all these pins RS, EN, D4, D5, D6 and D7 as I told before. Now we will come to void setup. Whatever we declare in this all are fixed. We won't be touching this part again. Pin mode, signal pin, we are giving it as input. We have to give the input signal. And pin mode, buzzer pin is obviously it is output. LCD.begin 16,2. Okay, LCD.begin, this is LCD.begin 16 is the width, height is the 2. LCD.begin width and height. And LCD1.cursor. Here it is LCD1.cursor. It is column, comma, row. Column is 0th column and row is 0th row. Okay. Now we will be printing show your hand at the starting. Whatever we print over here, it is fixed. And again we will be LCD1 dot set cursor 0, 1, where 0 is once again the where 0 is the column and 1 is the row. First row we will be printing this to ring the bell. Okay, so that's all this void setup. Now void loop we will be coming. Void loop, whatever will run in this void loop will run infinitely. Okay, here digital read. Okay, it is used to read digital value, as we know that, and digital read of signal pin. Okay, signal pin is assigned to which pin? Pin number 2. Okay, if it is equal to high, okay, this is a logical operator equal to, then tone of the buzzer pin, comma 200. Okay, this 200 is the frequency. Okay, frequency at which the buzzer frequency of the buzzer pin. Delay we have given it as 50. 50 means 0.05 seconds, as they take it in milliseconds, so again 50 hour, it's actually 0.05 seconds. And as we observe here, the delay is same for all. We have not touched it. Again the delay is same for all, and as we move closer to the as we move as we move closer to the switch, this the piezoelectric buzzer, the frequency, it's not the piezoelectric buzzer, it's the PIR sensor. The frequency keeps on increasing: 500, 900, 1000 hertz, 1300 hertz, and 1800 hertz. The frequency keeps on increasing, as we can see over here. And this is about the if loop. If this is the if this condition fails, then the else part will be executed. What are we having else? No tone, comma, buzzer pin. Okay. What does this mean is, if the PIR sensor is not activated, then no sound will be produced. That's all, guys. So now we will have a look at the simulation now. Okay, I'll start the simulation. Now as you see, it is telling show your hand to ring the bell. Okay, now this is the PIR sensor. Now when I okay guys, as you see over here, as we move closer to the PIR sensor, the frequency increases, and as we move farther away, the frequency decreases. So this is all about the simulation, and these are all the components which we have discussed, seen as before. So thank you.